in this video I'm going to show you how to sketch the graph of a function such as this one, which is a rational function. Now this one has a peculiarity because the polynomial which is on the numerator, it is exactly 1 degree higher than the polynomial that's on the denominator. In other words, the biggest exponent in the denominator, it's a square, and here we have a linear one. So this has a peculiarity. Instead of having a horizontal asymptote like the previous cases, it won't have a horizontal asymptote. That's why this one is crossed out. Instead, we will have a slant or oblique asymptote, which is called as well. That is to say, instead of having a horizontal asymptote, we'll have a line that goes somewhere around here. It will be an asymptote with a degree. Oh, sorry. And could be like this, could be, I don't know, somewhere around here, and well, we're going to find it out later. So basically, in order to sketch the proper graph here, we have to find these 4 elements. This one in here, the slant asymptote, the vertical asymptote, the x and y interception, and later on I will show you how to sketch the graph. Now I'm going to start with the one I think is the simplest one, which is the vertical asymptote. In order to find the vertical asymptote, you have to pick what's in the denominator and you equalize it to 0, will be x minus 5 equal to 0. In other words, the vertical asymptote will be an x in x equal to 5. So I'm going to mark it, frame it in here. This is my vertical asymptote. We check this out. So number 5 would be around here. I'm going to draw my vertical asymptote here as nicely as possible. Sorry, I'm not much of a drawer, as you can see. Oh, this is even too ugly even for me. Okay, there it is. That's my super nice vertical asymptote. Now I'm going to get for the y asymptote, which I think is the simplest now. I'm going to substitute to evaluate in here the f of 0. If I evaluate the f of 0, I will have here 0 squared plus 2 times 0, which will be as well a 0. I'm going to just write it directly. 0 minus 15, we get over 0 minus 5. Now at the end we can simplify this out. We will get a negative 15 over negative 5, and that would be, in other words, that f of 0 will be a positive 3. So let's say, in other words, my y interception will be at 0, 3. In other words, it will be somewhere around here. I'm actually going to use another color. I'm going to sign it with a blue for the interceptions. Would be somewhere around here, the y interception. And now I'll get for the x interceptions. In order to find the x interceptions, I'm sorry, I'm going to check this out. Now the x interceptions, we have to pick the factors or the roots for what's in the numerator. So I'm going to do it over here. Factor in this out would be a positive, maybe x plus 5 times x minus 3. Okay, that would be x squared. 5 times x minus 3 times x would be this one. Okay, it's fine. This will be over x minus 5. Now we have to pick each of the factors we got here, and basically we have to solve for x. I'm going to do it over here on the left. It will be x plus 5 equal to 0. It will be x equal to negative 5. And here I've got x minus 3 equal to 0, and x will be equal to 3. And here we got these two values that are telling us that the x interceptions would be at negative 5, 0 and 3, 0. I'm going to write them all here in the graph. It will be a negative 5, 0 will be around here, and the 3, 0 will be somewhere around here. Let's say there it is. Now we got the vertical asymptote, the Y and X interception, and now we are lacking to find the slant asymptote. In order to find it out, I'm going to pick this expression and I'm going to solve the long division. So I'm going to use a different color. Let's see, I want to use a okay, this kind of purple, I think it is, will be x minus 5. Let's solve the long division. Will be x squared here plus 2 times x minus 15. We don't have to leave any hole because we got all the exponents here. So I'm going to start dividing. X squared over x would be, I'm sorry, an x. So we multiply now this x by each of the terms. In here will be the denominator. So we get x times x squared will be x squared, and we write it directly as a negative squared, x squared. Now x times negative 5 would be negative 5 times x. So I'm going to write it as positive 5 times x. That will be all here. We subtract them all or add them all, would be 7 times x minus 15. Now we have to, as this one is just the same degree as the biggest x that is dividing, we still have to keep on dividing. So 7 times x over x would be 7 positive. Now I'm going to multiply this 7 by these two guys, would be 7 times x would be 7 times x. I'm just going to write it with a negative sign directly. Now 7 times negative 5 would be negative 35. So I'm going to write it as a positive 35. There it is. So these two will cancel out, and we got here it's a positive 20. Now, in other words, here I have to, this f of x, I can just rewrite it in this way. I'm going to write it over here, down here. It will be just the same as saying f of x is equal to x plus 7 plus 20 over x minus 5. Now, this x plus 7 will be our slant asymptote. The x plus 7 as a slant asymptote will be somewhere around here. I mean, the x interception, the y interception for this x plus 7 will be on, sorry, here, on the 0,7 will be somewhere around here, and the x interception would be a negative 7,0 somewhere around here. The other one was over here, so I'm just going to sketch a line as nicely as possible. I apologize in advance here because I draw really ugly. Well, imagine this is some sort of a straight line or just a diagonal here, and oh, actually this is too ugly even for me, but well, I guess that's the best I'm going to do anyway. So well, we got here all the significant points. We already got our vertical asymptote, our x and y interceptions, which is this guy, these other two guys, and we got our slant asymptote. Now the only thing missing will be to pretty much just join the dots, and in this case I'm going to just follow the pattern here I got. I'm going to cross out here the x-axis, then cross out the x-axis, going down, 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 and there will be my graph here. Now for the rest of the part, I mean, we can just try out some testing, but actually this one is pretty straightforward because it will follow, it won't cross this slant asymptote, and it won't cross this vertical asymptote. So we can pretty much assume it's going to be somewhere, something like this. Something like this. Now I'm going to show you just the graph in Desmos so you can see how it looks. And there it is, a bit nicer than mine, but I think you can see it's pretty much basically the same idea. Well, so that will be all for this example.